In this video, we're focusing on the short methods of differentiation. So we can differentiate a function to find its gradient function, which then allows us to find the gradient at any point on a curve. And the symbol for the derivatives is y equals f comma x. You also may see it as dy over dx, which is another common way of representing the derivative. So there's certain rules. Now the first one, the rule for differentiation that we're focusing on, is when it's a constant. So let's say we have some sort of function fx equals 4. If I go and then differentiate that, it equals 0. Then if I go and have another function that's fx equals 16 and I differentiate that, it equals 0. So the common trend there is when you're differentiating a constant, the differentiation is 0. So what this means is if there's no x, then the number disappears. All right, it's 0. Now, if we do have an x, a single x, so if fx equaled x, then the derivative of that would be 1x. All right, there was 1x, now there's only 1. Now, if I differentiate another function that is 2x, its derivative is 2. And then let's say to a third one, and we use fx equals 4x, and then I differentiate that, it equals 4. So the common trend here is when you're differentiating a single x term, the x is removed. Yep, so x became 1, 2x became 2, 4x became 4. All right. The next one is a little bit different, but we're going to cover it. So power is greater than 1. All right. So in all those examples there where we had a single x, its power was 1. What happens when we have a power that's greater than 1? So when we differentiate this, the power is brought out the front, and the new power is 1 less than the old one. So what I mean by that is here, let's say I go to find my derivative here. That 3 that's up here is now going to come out the front. So I get a big 3 out here. We still have the x. And to find my new power, it's going to be 3 take away 1. So the old power came out the front, the 3 gets brought out the front, and the new power is just going to be 1 off that. So the differentiation of x to the power of 3 is 3x squared. What if I had something such as fx equals 2x to the power of 4? Okay, so we do the same thing. If I go to differentiate this, that 4 is going to come out the front, and then we're going to minus 1 off. So we already had the 2, let's leave that there. We now have our 4, so times 4. The x stays. And now we have 4 minus 1. So our coefficient out the front is going to be 2 times 4, which is 8. Then we have our x, and then we have 4 take away 1, which is 3. So if you have an original function of 2x to the power of 4, and we go to differentiate that, the 4 comes out the front, like we did in the first one, and then it minus 1 off the new to get the new power. So we get 2 times 4, x to the power of 4 minus 1, and when we simplify that down, we get 8x to the power of 3. So when differentiating, remember, the power is brought out the front, and the new power is 1 less. So we're going to look at some examples. So here we have a function, fx equals 5x cubed plus 2x squared plus 3x. So we're going to differentiate this. So remember, this 3 is going to come out the front. This 2 is going to come out the front, and then this x is going to disappear. So what we end up with, if I differentiate this, is we get 5 times 3, the x is still there, my 3 minus 1, plus our 2 that's still here, times 2, x, 2 minus 1, and then over here we have plus 3. Now, you may think, why aren't we minusing 1 off the x at the bottom? Why don't we just get rid of it? So remember that this x over here, this 3x, if I write it up here, really has a power of 1. So when I differentiate that, right, the 1 comes out the front, like always. So we get 3 times 1 x, and then 1 minus 1. So that means we get 3x to the power of 0, and anything to the power of 0 is 1, so we just end up with 3. So that's the mathematical reasoning why the x just disappears. All right, so let's simplify this down. 5 times 3 is 15, x squared plus 4 x plus 3. So you always notice that your differentiated function, your gradient function, is always one less power for each term. So we had a power of 3, so it's power of 2. Power of 2, power of 1. Now, this middle step here, if you feel like you need to skip it, you can. There's no obligation to write it out like I did there. If you can go straight to the answer, feel free to. So we're going to do one more just to make sure we all understand what we're doing. So again, that 5 is going to come out the front, the 3 is going to come out the front, the 2 is going to come out the front, that x is going to disappear, and that 4 is going to disappear. So over here, we end up with f. Well, this time I'm going to write it like the other way we could write it. You can write it as dy over dx equals, so I'm just going to write the whole answer. So we got the 2 times 5, which is 10, x, and then 5 take away 1 is 4. 4 times 3 is 12x, take away 1 is 2. We get 2 out the front now, 2x, and then minus 2.